All right, welcome to The Explainer. Today, we are diving headfirst into some of the most mind-bending ideas in all of modern physics. And our guide is Brian Greene's incredible book, The Hidden Reality.
You know, for centuries, we've pretty much assumed that our universe was the whole shebang, that this was it. But what if it's not? What if everything we can see is just one tiny piece of a much, much grander hidden reality? Let's explore that.
So our journey starts with an idea that's actually kind of simple on the surface, but has some really profound consequences. It all hinges on one possibility, that space just goes on forever.
Okay, so think about it like this. In a space that's infinite, there are only so many ways you can arrange particles in a patch the size of our universe. So if you've got infinite room to play with, every single one of those possible arrangements, well, it has to repeat eventually. It's not a maybe, it's pretty much a mathematical certainty.
To really get your head around this, just think about a normal deck of 52 playing cards. The number of ways you can shuffle that deck is, well, it's that number right there. That's an 8 with 67 zeros after it. I mean, that is a staggeringly huge number. It's way more possibilities than there are atoms in our entire galaxy. And this is the perfect analogy for the quilted multiverse. Because if the universe is infinite, then somewhere out there, way, way out there, another you is living a life almost exactly like yours. Why? Simply because the cosmic deck of particles got shuffled in the exact same way. It means our lives, our choices, everything. It's all being played out again and again across this impossibly huge cosmic quilt. Wild, right? Okay, so that covers universes that are basically identical copies of ours. But what if other universes aren't just copies? What if they're fundamentally different? Well, that brings us to our next idea, the inflationary multiverse. So the theory of inflation suggests that our Big Bang, it wasn't a one-time thing. It wasn't the Big Bang. It was just a Big Bang. The idea is that inflation is this eternal process, constantly firing off and spawning brand new bubble universes.
I want you to picture this vast cosmic ocean of energy just bubbling away. Our universe is like a single bubble that formed and expanded within it and then cooled down enough for us to exist. But this process is happening all the time, creating a whole multiverse of separate, isolated worlds we can never, ever reach.
So, could the laws of physics be different in those other places? The answer is, oh yeah. And the reason might just come down to something called the Higgs field. You see, the Higgs field is what gives fundamental particles their mass. In our little bubble, its value is, well, it's just right. It's the Goldilocks value that lets stars and planets and people form. But in another bubble universe, the Higgs value could be totally different. Particles could be way too heavy to form atoms or have no mass at all. You'd end up with a universe completely alien to our own. It really feels like our very existence just comes down to a cosmic roll of the dice. Okay, so this all leads to an even deeper question, right? Why? Why do our laws of physics have the specific values they do? String theory gives us a potential answer, and it is absolutely staggering. So, according to string theory, there aren't just the 3 dimensions of space we see. There are extra ones, all tiny and curled up, hidden from our view. And get this, the exact shape and size of those tiny hidden dimensions are what determine the fundamental constants of nature here in our universe.
Now, brace yourself for this number. 'Cause it's ridiculous. String theory calculations suggest there are at least 10 to the power of 500. That's a 1 with 500 zeros after it. Different possible shapes for these extra dimensions.
So what does that mean? It means there's this huge cosmic landscape of possible universes, and each of those 10 to the 500 shapes creates a universe with its own unique laws of physics. Our universe is just one valley in that landscape. And the reason we find ourselves in this specific valley, well, it's the only one we could be in. It just happens to have the right laws for us to evolve and be here to ask the question. That's an idea called the anthropic principle. All right, so we've expanded space to infinity, we've tinkered with the laws of physics, but for our final step, our ultimate zoom out, we're going to question the very nature of reality itself.
You've probably heard of Plato's famous allegory of the cave, right? Prisoners chained up, watching shadows on a wall, thinking that's all there is to reality. But what if it wasn't just a metaphor? What if we're in a similar situation right now?
This is where it gets truly weird. This is the holographic principle. It's an idea that came out of studying black holes, and it suggests that our entire three-dimensional reality might just be a projection, like a hologram, of information that's stored on a distant two-dimensional surface.
And if you take that just one little step further, well, things get even crazier. If reality is really just information being processed according to a set of rules, kind of like a computer program, then how do we know we're not living inside an incredibly advanced computer simulation? The unsettling and kind of terrifying answer is, we can't ever really know for sure.
So, from endless copies of ourselves scattered across an infinite quilt, to the idea that our entire reality is just a holographic projection, these theories really challenge our place in the cosmos. They suggest that the universe we know and see every day might just be one page in a vast, hidden library of realities. It really makes you think, doesn't it?